as Ryan says, we'll take a closer look at these benchmarks within technology. Now, I can fully appreciate how overwhelming this can probably be from a primary perspective, because as a secondary teacher, I often find it quite challenging to sort of effectively demonstrate how a pupil is meeting or has achieved sort of different levels, particularly when we're asked as secondary teachers to track, well, what's the difference between a second level and a third level in this topic. Sometimes it can be a wee bit challenging. Tonight, we're probably not going to be able to give you a definitive answer, but hopefully we're going to show you some of the ways which might make this a wee bit easier for you in terms of from early all the way through to fourth. So probably early, first, second, you're maybe going to see that sort of the transition between primary and secondary. Your third and fourth, you're likely to see that towards the end of the BGE phase.
Selected one of the computing science organisers for designing, building and testing computer solutions. We'll discuss different ways in which you can progress from early to fourth level, as Connor was saying there, and discussing these experiences and outcomes and how the specified benchmarks can link. We'll still be using the microbits, as we'll show you how this can progress even further into the likes of Python programming beyond.
Yeah, so this early level is still sort of following on from, very similar to what we've been doing throughout the workshop so far, but it's just focusing on creating simple code. So that ability to be able to create these sort of tasks that we've been doing and then transferring it to a device, and the benchmarks that the early level, they just expect pupils to be able to program a simple task. So any sort of simple sequences that we've looked at, maybe on that particular Make Code Arcade website, there's, as you know yourself, there's so many easy introduction tutorials. But again, just the name tag activity is probably one that will just effectively complete that level for us.
Yeah, 100%. I mean, honestly, it would be nearly impossible to name the best way or the most effective one to go with. There's hundreds of options, and it really depends on what class is in front of you. But yeah, completely echo what Connor's saying there. So the code is really straightforward, consisting of only 2 blocks. For every block, a show string block. So not a lot to get a head around to start with. Pupils can use the show string block and change it to display their name. And then we can begin the process of differentiating that by challenging them to create one or more messages or display one of their own. So you're really kind of keeping that ball rolling for those that are really looking to progress and keep going with what they're doing.
Yep, so if we look at the first level, that's when you can maybe try and begin to produce sort of very basic and simple programming concepts. And again, so many different activities, but for this one here, probably the best one, and it's kind of similar to what we were talking about earlier with the random numbers. The dice activity is probably a good one to do as well.
Yeah, definitely. So this activity involves using the shake feature to generate a random number and then just simply display it. It gives teachers the opportunity to discuss data types, predefined functions, or even parameters at a very early stage. It's not things that you would necessarily think is going into that until you really break it down, but the world really opens up to talk about that at this early stage.
Yeah, so again, Ryan's demonstrated the building the blocks on that activity that we've just done there, but in this case, they're just placing the random block inside of the show number. And as traditional dice have only got 6 numbers, the same activity, you know, you can probably create this for different scenarios, and this is one of the important things that they're wanting to try and identify at that first level. It's basic problem solving skills. So you then start to think, right, if we're looking at a dice in terms of identifying random numbers between 1 and 6, can I maybe then try and get the pupils to think about how they could sort of create a task or a scenario where we're maybe still looking at random numbers, but maybe for a different situation.
Definitely. So I think one of the key activities that we could use for another sort of scenario could also be choosing a random pupil in the class. Pupils can count the total number of pupils in their class, change the parameters to match that number, assign each pupil their own number, and use this as a randomizer when the teacher asking the question. So once again, it's keeping it fresh. It takes away that idea of just look at task 4, let me know when you're done. The kids are seeing that this is reactive, it's different to their class, and it sort of allows the teacher to keep asking questions with that as well.
Yeah, so again, I think that would be a good way to keep the pupils engaged in the lesson as well, and it keeps them on their toes, because it's not just the usual, you know, maybe hands up that you're looking for in terms of answers being shared. If each pupil is going to have assigned that number, you can have one person that's going to be shaking it, and then hopefully everybody's going to be kept on their toes to see if their number's going to be picked out. But as a, hopefully it's a good way to try and keep them engaged in their responses as well. The benchmarks at that level, they expect pupils, in addition to constructing their code, they will also want them to be able to try and explain the steps that are involved and the expected output. So even if you can get one of the pupils to try and explain it in their own words about how they would possibly change it from a dice scenario into another scenario, that would be like an effective way for you to sort of measure their progress in them achieving this first level.
Definitely. So when we progress to the second level, you can see the term develop again. I've seen that before. So building has now been replaced by create, but we see a new term, which is evaluate. Now we'll take a look at some more detail in the snap the dot activity on the next slide.
Yeah. So for this one here, you're moving on to your sort of simple game creation and the introduction of sprites as well. So the aim of this game is probably fairly straightforward, to be honest. Up at the top left-hand corner of the screen, you'll see the micro bit, and the red dot that's shown on it, it's just going to move along that middle row there. It's going to move from left to right, and what the pupil or the user has to try and do is they need to try and press the A button exactly when the middle dot is going to light up. So the exact moment that red dot's in the middle of the screen, that's when you need to try and sort of snap that dot, if you like. They need to press that A button.
So to create this game, there is going to be a lot more program. That's obvious. We can see it from there. There is a little bit more complexity to this, but once again, it's using the same blocks that at this point we've got a good amount of exposure to. So we need to create the three scripts shown at the top left-hand side. One to create the sprite where the game starts, one to move the sprite throughout the game, and then one to actually calculate the score. So you're sort of bringing the three different stages into that there. So that could be done in a number of different ways.
Yeah, and again, like once that code's been finished, you can then challenge pupils in class to see who's going to get the highest score. Once the game's finished, it will display what score the pupil got. So again, like anything, if you sort of bring in that element of sort of competition or challenging one another, that usually, I find from a secondary perspective anyway, I'd imagine it would be the same from primary, keeps them more engaged. It gets the learning and interaction a lot more fun. But the score concept is quite important because that's one that's explicitly stated in the benchmarks. The pupils need to try and identify patterns in problem solving. So the specific example they give is a score counter. So that's why we think that this activity here would be a good way for you to measure their progress against second level.
Lovely. And then from this, the teacher can simply introduce the idea of evaluation, which is that new term that we're talking about, would help meet that benchmark of identifying mismatches between the task description and the solution. And there are some different ways that we can do this. Yeah,
so if you're wanting them to try and evaluate it, and again, there's so many different ways that you can do this, but one possible way could be asking pupils just their opinion of the game and how it could possibly be improved. So some ways that I've tried to do this, and again, some of them might be different in terms of primary and secondary, but maybe 2 stars and a wish might work for that. You could maybe give pupils sticky notes, and then they could record these answers, and then that gives you the opportunity to sort of collect those notes in, and you can discuss it together as a class.
So another option you could also do, you could allow pupils to take part in peer evaluation. It's one thing that we know pupils aren't shy about, and it's telling you they like or don't like something, so give them an opportunity to do that in a constructive way. Down at the bottom right-hand side of the corner of the slide, we've included a little grid template that could be used to assess that progress that a pupil has made in creating the code. But once again, that's very much a guide. You could use that and adapt it to your own classmates.
Yeah, so if you were looking at aspects of the game, a simple one could be, does the correct score appear at the end of the game? And if it doesn't, then you could identify like possible problems. Have they maybe put that down at the bottom left? Have they maybe put that change score by 1? Have they maybe put that in the wrong place? Have they maybe put that underneath the else by accident? Or have they maybe, instead of putting in for your X coordinate being equal to 2, have they maybe tried to change that number as well accidentally if they put in the wrong one? But it gives pupils a very early opportunity to try and look for errors in other code, and it improves their understanding as well about how they can probably try and rectify errors.
So once you've completed that evaluation, ideas can then be gathered, and that could help improve the game. A couple of suggestions are the speed of the sprite and the scoring system.
So the speed's probably when you play the game, the speed that it's set to, it does move fairly quickly. So if pupils find that a bit challenging, then they could increase, just where I've sort of highlighted that pause block in the red circle there, the red oval, they could increase that number so that the amount of times the dot is moving, it's slowed right down so that it makes it easier for the pupil to sort of snap that dot right in the middle. However, if there are a couple of pupils that think, no, this is too easy for me, I want to make it a wee bit more difficult, again, you could sort of reduce that number and it would have the opposite effect where your sprite is going to speed up.
Exactly. Another idea is, well, you could also change the scoring system so it's more similar to a target. You can make it the aim of the game to snap the dot in the middle of the screen, and we could award, say, 5 points. If the pupil snap the dot in the position before or after the centre, we could award 3 points. The dot was snapped to the furthest left or furthest right, we award 1 point. So still an idea score, but it's not a case of like on or off, yes or no, you got it or didn't. It's award, that range of award that people could get.
So overall, this activity here, I would say it gives us a good foundation for meeting the second level, because there's those different terms that have been introduced. So in addition to just being able to create something from your microbit website, it's all about doing those additional things as well. So once we've created the game, can they evaluate it, but can they also develop it as well by putting in their own sort of alterations and their own sort of ideas into the game as well?